In the previous video, we were able to talk about how to solve the vertex of a quadratic function. For this time, we are still going to talk about the vertex of a quadratic function, but we are going to use another method. This method will actually help us to transform a quadratic function into its vertex form. Let me share to you the same four examples in the previous video. And for that, I'm also going to give you the vertex for these points that were discussed in the previous video. You may want to check the other video for that. The vertex for number 1 was actually at 0, 0. And number 2 is 2 at and negative 4. Number 3 is negative 4 and negative 21. And finally, for the last, you have 2 and negative 5. Okay. These are your vertices for the given functions in as discussed in the previous video. Okay, so let us try to uh, resolve them. So these are our goals, but using the vertex form of the quadratic function. The vertex form of quadratic function is actually expressed in a form of f of x equal to a x x minus h squared plus k. Our vertex here is actually the point of h and k. Right? So we are going to express this four quadratic functions in this form, and then whatever the value for x minus h, you take the h there and the k, those are your vertices. So okay, how do we do this? So let's start with number 1. With number 1, it was already obvious that the vertex here is 0, so we need to reach that one. How do we express this? We are going to actually include here um, this completing the square method. Okay, we are going to use the completing the square method here, but since this expression here has no second term, so we take note of the completing the square method. We need to solve for the c using the formula of b over 2 square root of a, and then you have to square it. Okay? That's a formula in solving the vertex. But right now, we don't have b. So how do we express this in the vertex form if it has an expression? Simply, you could actually say this is actually x minus 0 squared. Am I right? Because any number subtracted by 0 is the x itself. Right? So 2 minus 0 is just 2. 5 minus 0 is just 5. And then 3 minus 0 is just a 3. So we have this expression. Okay? And then we could also add here another value of 0, which actually means nothing because any number added by 0 will just be a 0. It will be the number itself. So this is actually the vertex form of this expression here, x minus 0 squared plus 0, where the a value is equal to 1. And then your vertex now is just the value of the h here, which is 0, and the value of your k here, which is also 0. So take a look at this. Using the vertex form, we have the same vertex here as solved in the previous example. Again, I would just like to make a emphasis. In number 1, since we don't have here any b or c coefficients, we cannot use here completing the square, but we may express it in this form just to emphasize that the vertex is 0 and 0. But for number 2, since we have a b coefficient here, we could express it. You can use the completing the square method here. And how do we do that? Okay, we are going to have f of x is equal to x squared minus 4x, and we will add here a term that will make it a perfect square trinomial. The perfect square trinomial will help us later on express in terms of a square of a binomial. And what is that value? We will use here c is equal to b, which is negative 4, over 2 times square root of a, which is 1. This is negative, and then square it. So we have here square root of 1 is 1. 1 times 2 is 2. Negative 4 over 2 is negative 2. Square it. So you will add here plus 4. By adding plus 4, this is now a perfect square trinomial. As you can see, the first term is a perfect square. The last term is also a perfect square. And the coefficient here of the middle term is just actually that's the double of the product of the roots of the first and third term. Square root of the first term is x. Square root of the last term is either positive or negative 2. And then you double it, so you have positive or negative 4, which is one of it is negative 4. This is now a perfect square trinomial. However, it should be understood that when we added 4 here, these expressions are not anymore the same. So how do we make sure that this expression, even by adding 4, we were not deviating from the given? So how do we do this? We're actually going to subtract here another 4. And how is that? Because 4 minus 4 will actually be 0. And if we're going to have this as 0, that means we just have the same value. But we are not going to make it 0 because the goal here is to come up with a vertex form. So what we're going to do here is to group this now. Okay. So minus 4 will just be placed outside. Okay. And then this is what will happen here in the inside. And then you can now make this as a square of binomial. You have square root of the first term is x. Square root of the last term is positive or negative 2. But which of the two? Use the sign of the middle term. Minus. You have square. And then minus 4. This is now the vertex form for number 2. I would like to repeat how it's done. Earlier, we completed this. We added here a constant so that the function or the expression here, rather, will become a perfect square trinomial. So we use here the completing the square method. When we added 4 here, we have now created a perfect square trinomial. But when we added 4, it now deviates from the given. So how do we nullify what we add here as 4? We are going to subtract another 4. So that 4 minus 4 will just be 0. So we are just adding 0 from the given. But we have completed here a perfect square trinomial. We group this, express this group as a square of binomial, leaving here 4. So what is now our vertex? The vertex is, okay, given by the f of x. Let me rewrite it. F of x is equal to a x minus h, the square of x minus h plus 4. Okay? This here, this is our h. And what should be our k if this is minus 4 and this is plus 4? I plus k. This is plus k. This is plus k. So we already have our h, x minus 2, x minus h. So you take the h, which is actually 2. And how do we determine the other value? If it's minus and this is plus, take note that this could be further rewritten as x minus 2, or the square of x minus 2 plus negative 4. Plus negative 4 is just similar to minus 4. So by expressing in this form, we have here plus k, which is actually negative 4. So look at this. This is our vertex using a vertex form. This was our vertex in the previous video. You might want to check that out. We do have the same vertex. Okay. So the goal here is just applying the vertex form. Number 3. So number 3, we could have here f of x is equal to x squared plus 8x. And I'm going to move out a little bit further the minus what do you call it, minus 5. Okay. Why? Because I need to add here something so that this could actually be a perfect square trinomial. And what value is that? Using the completing the square method, c, not this c, but the new c here, again, not this c, the new value for c is 8 over 2 square root of 1, and then you square it. So square root of 1 is 1 times 2 is 2. So you have 8 over 2 square. Have we squared earlier? All right. So this is actually 4 squared. The value of c you need to add is actually 16. That is what we're going to place here, plus 16, so that this group now is now a perfect square trinomial. Okay. Next, what is now the item here to be added here so that we could neutralize the plus 16? We simply subtract here another 16 so that we are just adding 0. 16 minus 16 is just 0. We are adding 0 to the given. So we are not changing the value of the given. We are not changing the value of the given, but we are changing the structure of the given. Again, not the value, just the structure. That is then maybe simplified to the square of this binomial, square root x. Square root of 16 is 4, positive negative 4 rather. But which of the two will be used? Use the sign of the middle term plus. Squared. Combine here, you'll have minus 21. Or this could be expressed, okay, later lang. This is our vertex form already. Okay, so our vertex should contain the minus, this is the vertex form kasi. You have a x minus h squared plus k. But this is plus, this is minus. How do we make this similar to the expression of the vertex form? We could actually express this further as f of x so that we could have a pattern here. We have here x minus negative 4 square. Double negative property plus. Okay, again, the double negative property here will just be plus, so they are just the same. And why do we make it this form? So that we have a parallel here, minus. And the other side here, what happened earlier here, so minus 4, just change it to plus negative 4. Do the same thing here. This is plus negative 11. So that we could actually get our vertex with h, sorry, not that. H, which is negative 4. Let's use the color for the vertex, which is blue. Okay, and use here the green. So x minus h is x minus negative 4. That's actually negative 4. And then you have here your plus k or plus negative 21. That is your second partner. Look at this value and the value here. When we solve it in the previous video, they're just exactly the same. Okay. So this is also the vertex when we use the vertex form. This is the vertex form. Okay, this is the vertex form, and this is its equivalent form when expressed in minus and then plus. How about number 4? Number 4 could be expressed as f of x. You have here 2x squared minus 8x, and I'm be moving 3 here farther. To complete this, again, we use the formula for c. That's negative 8 over 2 square root of 2, as a is 2 squared. That's negative 2 over 4 over 2 is actually negative 4 over square root of 2. And then use the power law, share the exponent. The square of negative 4 is 16. The square of square root of 2 is just 2. So the what will you add here is actually positive 8. So you will add here positive 8, and you will subtract here 8 just to nullify what you have added. Okay, so you have this grouping and that grouping. Next is to express this as a square of a binomial. However, this is not actually a perfect square. It has a perfect square trinomial, but this is not a perfect square trinomial since it has here the first term is a perfect square as well as the last. Okay, how you will do this? How you will actually solve this is you could actually factor 2, and you will have x squared. Factor 2, you have 4x. Factor 2, you have plus 2. And then combine here minus 5. You have you have they got factored 2 here, and that will be your a. So you can further combine this. This will become 2. And now This is a perfect square. Simplify it. Square root of the first term. I am perfect square. I've been saying perfect square, right? Perfect square trinomial. So you have here the square root of first term is x. Square root of the second term is plus minus 2. Which of the two? Minus squared. And then minus 5 here. Okay? So this is now your vertex form. Vertex form. Here, these are also your vertex form. And of course, this is your vertex form. Okay? So how do we determine the vertex here? Take note that the vertex is actually given as a. Okay, the vertex form is a x minus h, and then you have the square of the binomial here, plus k. So your vertex is h and k. So you have here your vertex as your h, which is positive 2. And again, this could be expressed as, okay, where do I need to write this one? This could be expressed as f of x is equal to 2x minus 2, the square of x minus 2 rather, plus negative 5. So your k plus negative 5, the k value or the y coordinate is negative 5. So this is your vertex. Check here earlier. You have the same vertex as what we did in the previous video. Okay? So we've been emphasizing the purpose of the vertex. That's why we have many methods in solving for the vertex. Number one, the previous video. Please check the previous video. We have the formula for solving the vertex. And also, this video covers the concept of transforming the quadratic function into its vertex form so that we could determine the vertex. Okay? So here are the vertices now. So thank you for watching, and please be excited for the remaining videos for the second grading. I believe we still have 3 to 4 videos. So just stay tuned and please prepare for your assessment. Goodbye.